During this week's lab, we are going to be looking at 8 different experiments looking at chemical and physical changes. That may seem like a lot, so we're going to have to divide up the work. It's important that we also keep social distancing, but we're going to have to be able to demonstrate for the people at our lab bench what we're looking at for each of the different sections. Some of the sections are going to require you repeatedly looking at the same experiment over different periods of time. And so what that means is you're not always going to be recording your observations in order. Sometimes you will be skipping back to an experiment from before, or you may set up an experiment that will look at the data later on before you proceed in the order that is in your lab manual. At your desk, you will find a piece of paper that tells you which experiments you are going to be demonstrating, and you will also find 2 baskets. One basket will have different elements in it. This is the smaller basket. There should be 2 elements, and they should be labeled, either on the element itself, there's a label on the bottle, or there might be a card on the inside showing you what the element is. Look through your lab manual now and see what types of observations you're supposed to make for each element. Make a table so that you have a spot for each of the 8 elements and columns for each of the observations that you're supposed to make, including things like color, what phase the material is in, and is it metal. Make sure there's enough room for you to write all of the observations in place. Your basket will only have 2 elements, so for part A, once you're done observing your elements, you will pass the basket to the next person at your lab bench until everyone has seen all 8 elements. The other basket at your lab bench will contain materials for 1 or 2 of the other experiments. This basket contains materials for experiment C, including copper chloride and aluminum, and for experiment F, including lead nitrate and potassium iodide. Your directions will tell you what you're supposed to do and when with these particular experiments. It is important that when it says set up the experiment now that you do that so that you're ready to go when it's your time to demonstrate your particular materials. After you have observed the elements, everyone will stop what they're doing and pull out the materials they need to demonstrate their particular experiment. So regardless of who you are, you're not going to start on experiment B right away. You're going to set up your experiment first. In some cases, the lab manual suggests exactly what you're supposed to record in your notebook, such as the temperature or the color of a particular material. Sometimes it just says record your observations. It's important that you're looking for the things that a chemist would look for. Don't write things like nothing. That's very vague. All that tells us is that you haven't observed anything unusual, but it doesn't tell us what you have observed. When you're observing a liquid, you want to indicate the color and whether it is clear, cloudy, or opaque. There is a difference between clarity and color, and we'll talk about that in just a minute. If you have solids, you might want to notice if they're powdery or crystalline. You might want to take note of the color or if they look metallic. You might want to notice whether or not that they dissolve in water if that's part of the procedure that you are doing. And then if you have a gas, as you might have with your elements at the beginning, you might want to notice if the gas has a color and if that gas, which is probably in a balloon, floats or doesn't float. And what does that tell you about the relative density compared with air? So these are the kinds of observations you want to make sure that you have in your notebook. Most of the experiments will require you to do part of the experiment in a test tube. You have a test tube rack and test tubes in your drawer. Go ahead and pull this out. Depending on which person at the lab station you are, you might have 1 or 2 test tubes, or you might use 3 or 4 of them. Among your observations, you're going to determine whether your material is clear versus cloudy and whether or not it has a color. Now, these terms, when we use them in everyday life, sometimes get mixed together, but it's important that we distinguish them in chemistry because they tell us some important things about our liquid that we're looking at. Make sure that you look at the liquid when it's in the test tube and not in the bottle. The bottles themselves are not quite clear, and so you may not be able to observe all of the properties very well unless it's in the test tube. First, let's look at color. These two test tubes contain liquids that are different colors. One is purple and one is colorless. Now they're both clear. The one that is colorless might be the one you think of as being clear, but clear just tells us that we can see through it and there's nothing getting in the way of that. There's no cloudiness. So I'm holding this up to this blue line that appears through the test tube. We can see that those are clear. One is colored, one is colorless. Now if I have some sort of cloudiness in there, I can also describe the extent to which it's cloudy. So for example, this first test tube, I might be able to see the blue line through there, but I can also tell there's some cloudiness. So this is a cloudy test tube, and what that tells me is that there is a solid precipitate in there. This test tube also has a solid precipitate in it, but it might be so thick that we can't see the blue line through it. We would call that one opaque. The important thing to remember is that there is a distinction between clear and colorless. Colorless tells us whether there is a color there or not. Clear tells us whether there is a solid there or not. At your lab bench, you will find a large basket with materials in it. These are labeled for one or two of the experiments that you will be doing in lab. You are in charge of demonstrating this for your entire lab bench. Each basket will have different materials, so the only way that you will be able to make all of your observations is by taking turns demonstrating each of the different experiments. You are also responsible for the disposal for this particular procedure. So when you get to the end of your section, make sure that you know how to dispose of any residue or materials still left in your test tube or beakers. You're going to set up part C before you do the experiments for B and the other experiments. This is because part C and part D are going to require you to make several observations over an extended period of time. Place about 20 milliliters of water in a beaker. You don't have a 50 milliliter one, so use your 100 milliliter, or if you have the smallest is the 150, use the 150. When you set up your experiments that involve test tubes, D, F, and H, you will find that each test tube has a blue or white spot on it that you can write in pencil to label it and keep track of what's in it. Some of the test tubes that you have been given may not have these. In this case, you may use a Sharpie to write on the test tube itself what the material is. But you'll need to make sure that you ask your TA or your instructor how to remove this ink so that the next time the tube is used, it can be labeled as something different. For Part B, there are a few small changes from what is described in your lab manual. Instead of doing this over a Bunsen burner, you're going to use a hot plate, as iodine will sublime only a little above room temperature. You're going to have a beaker from your drawer, but you're also going to have a plastic beaker to hold the ice. Remember that this does not go back in your drawer. Your iodine vial may still be clear, or it may have become dark from reaction with the iodine. When you open it, you may notice that the iodine may have corroded the lid as well. Iodine is a strong oxidizer. From your drawer, bring out your 250 milliliter beaker and your watch. Place a few crystals of your iodine in the beaker. Make sure to record your observations before you begin the experiment. Observe closely because the iodine actually has a color to it other than just silver. Once it is in the beaker, you're going to take your beaker and place it on top of the hot plate. Place your watch glass on top of the hot plate and place a couple pieces of ice on top of the watch glass. And now you're going to turn on the heat to medium-high. It will take a few minutes for the heat to cause the iodine to start to sublime. You will notice a color in the glass as it is vaporized. The ice will cause the vapors to redeposit on the underside of the watch glass. After you have observed for several minutes, you will remove the ice and the watch glass and observe the underside of the watch glass to look for redeposition.
Think about whether these changes indicate that this is a physical or a chemical change.
The first thing you're going to do is make sure everybody has a chance to observe the copper chloride crystals that are in the small vial. Pass around to your classmates so they can record their observations in their notebook. Then you're going to add a few small crystals to the water in your smallest beaker. Observe any changes when you just put the mixture in the bottom and after you have a chance to stir it. You may want to use a glass stirring rod to stir the material. Remember what you're looking for with a liquid. Then you're going to set up the temperature. When you are using a thermometer, it is important that you leave the thermometer in the place where it is taking the temperature for at least 40 seconds. Otherwise, it won't have time to equilibrate with the liquid or the solid that it is near. Then you're going to add your piece of aluminum foil. You can add this by putting one end in and then folding the other end over the glass so that you can compare what happens when it's in the copper and when it's not in the copper. After you make your initial observations, you'll go on and do some of your other experiments and then return when your paper tells you to make your next set of observations. For Part D, you're going to set up your test tube ahead of time to allow people to observe the liquid, and then you're simply going to take the copper wire and place it in the test tube. For Part E, you'll start with a few grains of zinc in the bottom of your test tube. Let everyone have a chance to observe what the granules of zinc look like before you add the material. Then it's just a simple matter of adding a few drops of the hydrochloric acid and making your observations. This reaction happens very rapidly, so you don't need to wait on this one and return to it later. When you do reaction F, you'll start with the potassium iodide in the test tube. Observe the clarity and color of the liquid, and then you will add the lead nitrate directly to the test tube. This reaction is also fairly quick.
Be sure you do this part of the procedure over the glass plate to protect the counter from the extreme heat from the burning magnesium. Part G is fairly simple, but there are a few small changes to the procedure. You will need a small piece of magnesium, and you will need a watch glass. This kind of looks like a big contact lens. This will be to collect the residue after you complete Part G. Instead of doing this procedure in the fume hood with the Bunsen burner, you're going to use a lighter. This will be sufficient to get the reaction started. No fumes will be produced during this reaction, so you don't need to be in the fume hood. You are also going to need some crucible tongs. In your drawer, you will find two things that look very similar to one another. The larger item is the crucible tongs. Notice how the ends come together at the tip. This will be helpful in holding on to your magnesium strip. The smaller item is the test tube clamp. The test tube clamp has a rounded opening. This is to hold on to the test tube and isn't as good for holding on to the thin piece of magnesium. Be sure to observe the magnesium before you light it so that you can compare and contrast with the residue after you light it. You may wish to uncoil it a little bit and bend it backwards so that you are only lighting one end of it. Grasp the coil in your crucible tongs and light one end. Hold this over the watch glass. Once it lights, remove the flame so that you can observe the burning action without the added fuel. It will be quite bright, so you may wish to turn your gaze slightly to the side. Place your residue in the watch glass and make your observations. Don't touch the residue because it will remain hot. You will want to wash your crucible tongs before replacing them in your drawer.
For experiment H, you'll be using mineral oil. While mineral oil generally comes in containers such as this one, you will be using a small portion that is in your basket. For part H, you will start with a test tube of oil and a test tube of water. While your directions tell you to fill each halfway full, you will find that if you only fill the oil one about a quarter to a third full, it will be easier to clean. After you've made your initial observations, simply add a drop of the food coloring to each of the test tubes and observe what happens.